Good morning all. So welcome back for discrete mathematics learning. Today's topic is derangements. The prescribed books are being used as material content. Kenneth Rosen, Joel Mott, or few of the Google material from the above links: algebra.com, oasis.org, quizlet.com, math.libertex.org. So the first term which is being highlighted is derangements. So it is related to the or similar to the word arrangements, right? So what is an arrangement? Arrangement is some order. Sit in a queue as per your heights. Okay. Stand as per your weights, increasing weights or decreasing weights. So that can be an arrangement. Order the numbers 1, 2, 3, 4, 5, 6. Make alphabetical ordering A, B, C, D, like that. So that is what is an arrangement. Derangement is the exactly opposite of that. Whatever is the natural position, whatever is the natural order of a letter, of an object, of a number, that should not be maintained. That is what is called as derangement. For example, here, what we see here, 1, 2, 3, 4 is arrangement. But suppose 1 is not in its own position, 2 is not in its position, 3 is not in its position, 4 is not in its position. Position means natural position. Then it is called derangement. For example, here, what about this 1 and 2 in the first row? 1 and 2 are in their natural order, natural position. 2 comes after 1. But what is derangement for 1 and 2 here? 1 should not be in 1's position, 2 should not be in 2's position. So this possibility we have shown. Instead of 1 we have 2 now, instead of 2 we have 1 now. So this is the example of derangement made for this first row 1, 2. So how many such possibilities are visible here? Only one possibility. Similarly, now 1, 2, 3 are in a natural order. So if I want to derange 1, 2, 3, what it indicates? 1 should not be its position, 2 should not be in its own position, 3 should not be in its own position. So this is one arrangement. 3, 1, 2. This is one arrangement. 2, 3, 1. This is one arrangement. 3, 2, 1. Here the first two, that is 3, 1, 2, 2, 3, 1 are the examples of derangement, while 3, 2, 1 is not an example of derangement. Why? Because if you look here, 2 is in its own position. 2 is in its own position. So with this, what we understand, derangement means no element should be in its own position. No element should be in its own position. So if we have 3 numbers here, how many ways are possible for derangement? 2. If we had only two elements, one way was there. If we had 3 elements, 2 ways were there. Now similarly, we have 4 elements now, 1, 2, 3, 4. So these 4 elements, if they need to be deranged, if I do it manually, I see that it can be done in this fashion: 2, 1, 4, 3, starting with 2, starting with 3, starting with 4, and none of them is starting with 1. That you have to remember. So if I see all this combination, there are 9 ways. Now some interesting question, let us say. There are 4 students and a test was given by the professor to those 4 students. So A, B, C and D, and professor says that you grade your peers, not yourself. Okay, so no student should be giving grades to his own test. So what are the possibilities? What are such possibilities that no student should receive their own test? Okay, so actually First of all, how many objects are there here? A, B, C, D. Four objects are there. So how many possibilities, permutations are possible? 4 factorial. 4 factorial means how much? 24 factorial. 24. So these 24, out of these 24 combinations, we have to identify such combinations wherein the student will not get its own grade. Okay. So here, if you see this blue colored combinations, these blue colored combinations are the examples of students not getting their own grade verifications. So there are, if you count these blue colored one, 1, 2, 3, 4, 5, 6, 7, 8, 9, there are 9 such possibilities. So 9 derangements are there. So let us go back again. Okay, what is derangement? Natural position should not be there. 1 should not be at 1's place, 2 should not be at 2's place, 3 should not be at 3's place, 4 should not be at 4's place. So for uh, these two objects, one derangement is possible. For these three objects, two derangements are possible. For these four objects, 9 derangements are possible. Okay, so suppose we are starting with 0. For 0, okay, so one possibility is there. Okay, so like that. For next possibilities are 2, 9, 44, 265. For example, what is the 2 number of ways? The 2 number of ways possible is for 3 objects. For 4, 9. So that's why we are coming 9. So for 5, 44. For 6, 265. Like that possibilities are there. Now, D5 indicates derangement for first 5 numbers, let us say 1, 2, 3, 4, 5. So as you can see from this table also, D5 value is 44. But there is a formula for derangement, which is a generalized formula given by Dn, and in some literature it is written also like this, factorial n. So the formula for Dn is n factorial in the bracket 1 minus 1 by 1 factorial plus 1 by 2 factorial minus 1 by 3 factorial plus last minus 1 to the power of n 1 by n factorial. This is the formula. Now this formula works if the number is small. If the number is large, this formula will be given as n factorial multiplied by e to the power of minus 1. And what is the value of e to the power of minus 1? That is 0.369. So what is the definition of large numbers here? The definition of large numbers is n greater than 7. Okay. Now, so you should, using this formula, you should be easily able to calculate D5. What will be, so what you have to do here, you should replace n with what? 5. So 5 factorial, 1 minus 1 by 1 factorial plus 1 by 2 factorial minus 1 by 3 factorial plus 1 by 4 factorial minus 1 by 5 factorial. And if I calculate that, the answer should come 44. So permutations are possible for what? If n are there, n factorial. Now let us look at one example. There are 6 balls. Each ball is of different colors. Okay, and there are 6 boxes, okay, of again matching colors. Per ball of one color, box of one color, like that. Now, how many derangements do you have if no ball is in a box of the same color? So it means what? You are looking at 6. So you have to find out D6 actually, just as you have Dn or you have D5. Now what you have to find out? D6. D6 means what? You have to replace this n with 6. So 6 factorial is equal to 1 minus 1 by 1 factorial plus 1 by 2 factorial minus 1 by 3 factorial plus 1 by 4 factorial minus 1 by 5 factorial plus 1 by 6 factorial. So you have to calculate that. So same thing here. So if you calculate that, it is coming to 265. You can see here 265. So it means what? 44 is for D5, 265 is for D6. So D7, D8, D9. So this is D5, it is D4, this is D3, this is D2. This is D1, this is D0. Next example here is find the number of derangements. And what are the numbers? What are the numbers? The numbers are 1, 2, 3, 4, 5, 6. Now here the first three numbers are 1, 2, 3. That you have to maintain. The first three numbers must and should be 1, 2, 3. That you have to maintain. But they are in some order. You have to list out all such derangement. Now, how many numbers are there totally? 6 numbers. Out of that, the first three numbers will be 1, 2, 3. So, we have to find out the derangement for 1, 2, 3. So, derangement for 1, 2, 3 is D3. So, you have to calculate D3. So, you have to calculate D3 means what? Even if you replace here with formula, D3 means 3 factorial 1 minus 1 by 1 factorial plus 1 by 2 factorial minus 1 by 3 factorial. So if you calculate D3, you know it is 2. Even in the beginning example, suppose the objects are 3. We are shown here. If the objects are 3, there are two ways. There are two ways possible. Two combinations are possible for derangement. So what are the remaining numbers now? 4, 5, 6. Again you have to calculate D3 for them. That should be 2 only. Now the total derangement will be the product of D3 and D3 for 1, 2, 3 and 4, 5, 6, which will be coming to 2 multiplied by 2, which is 4. So you have to arrange the derangements or list the derangements in such a way that there will be 4 combinations, and they should all begin with at least the beginning one should be 1, 2, 3. These numbers should be there at the first 3 positions. They can be any order. So this was a small topic called as derangement. Hope you will understand it. It's a simpler topic.